So my name is Michael Getz. I'm in the Glacier Lab today. In this first half, we will really just be going over how to set up the compiler for CompuCell, and we won't really be going past that. So if you do already have CompuCell set up in the compiler environment, as in you're building it from source code, this will unfortunately not be very helpful, but it will be very helpful for getting everybody up to speed if they want to follow in the afternoon session. So really quick, because it will take a little bit, you will have to set up your Conda environment. So for Windows, you all should have seen some sort of YAML file that was distributed. For Windows, it will be the NCC3D 2026 YAML file that corresponds to Visual Studio 2026. And then for Mac Linux, you'll have your own compile file. And these can all be linked from the bottom. So I'd encourage you, please build this environment through Mamba, preferably. Conda will work, but it's very slow. Another point to be made here is you can do this in Mini-Conda or Mini-Forge. Personally, Mini-Forge ends up a little bit better because it can handle Mamba a bit more natively, and it gets a little less confused than Conda calls. Okay, all you have to do to create this environment is just Mamba env create. You put the file path to your YAML file. It will then create an environment dependent on the name provided within the YAML file. If there's already a name there, you should then, it'll run a whole bunch of stuff in the background. But kind of jumping forward here, I'll let you guys do this if you need to do this. Okay, feel free to ask questions if you feel like I'm going too fast, but I'm going to start on the introduction while this can go in the background. We will come back to a slide that does show this again. So today I'm going to be talking to you about why do we want to extend CompuCell, how to compile CompuCell, as in what's needed, how do we make a clone of the source code, what kind of compiler do we need, our Conda environment, how to set up CMake, and then how to actually compile. I'm going to be walking through how to do it from the Windows perspective, but it is really actually a lot easier in the Unix platforms because you can just use Make natively. So what do we gain by extending CompuCell3D? Why are we going to go through all this effort to make this compiler environment as opposed to just running the let's say the executable to install CompuCell onto your computer? So one thing that you do gain is by compiling it from source code, you can now create your Steppables in the C++ layer. The fastest thing, the best thing about that is it's a lot faster in C++. So if you have a simulation that is spending a lot of time in the Python layer, with your end time report, then it may end up being worth effort trying to recode it into C++ and run it to try to save computational expense, especially if you're looking at possibly sending this as HPC runs. So one, you can make C++ Steppables, which is much faster than Python, purely because C++ is a compiled language. Two, this compiler environment will now allow us to interact directly with the innermost loop, as in the energy functional, and it will allow us to make modifications of that energy functional on a sub-MCS frequency, right? So we talk a lot about the MCS. Every MCS, you have a certain number of flips that occur. So now, by compiling CompuCell, we can affect how those flips occur, and then when a flip is accepted, we can then make changes to the system reactively so it continues with its current state. So compiling and utilizing the C++ level lets us edit the copy attempt and probability itself. So fun fact, all the plugins using the previous sessions are written by the same pipeline. You will be later creating your own plugin, which then you can utilize. So we're not going to fully describe this problem, but it's what we're going to be talking about later is cell spreading. So it's going to be roughly based off a paper by Albert and Schwartz in 2014, where they were looking at patterned fibronectin and looking at how the cell would spread across this patterned substrate. So the name of this paper is Dynamic of Cell Shape and Forces on Micropatterned Substrate Predicted by Cellular Potts Model. And we will need to create a CompuCell3D module that tracks and dynamically affects the energy dependent on these adhesive contacts, right? So it's going to want to sit on these patterned areas, but it's going to want to do it in a way that makes it different than something like the contact plugin or contact energies. It's going to do it in some nonlinear fashion that isn't currently described. So if we look at how they define their energy functional, they have 4 terms, but really what we're going to focus on is this 4th term, this adhesive energy term, which is just how many of the cell object, how many how many of these sites are occupied by that cell object. And the cell will try to, basically, I mean, this is a Hill function, or this is a Michaelis-Menten, really, that basically the amount, this energy contribution will start to saturate out the more binding sites, or the more sites in this adhesive energy term are currently bound, right? So for the exercise later, we're only going to be adding the 4th term, or being concerned by the 4th term. So we want to add some energy applied by a finite number of adhesive sites on cells. So as it starts to spread, as it starts to occupy these more adhesive sites, this the amount of energy that's provided to the cell object is lessened as it starts to saturate. So as is, how do we all present here think that we could implement this into CompuCell? If you saw this 4th term and you said, I need to get my simulation to do this, how would you think you could do this? Okay, that's an idea. So a second cell layer with contact energies, or alternatively, something like an underlying field that the cells can read, right? So that's a good solution. The issue is when you apply that to the system, if you don't have this 4th term in the energy functional, you're missing this kind of global sensor of the number of cell occupancy sites of the cell object, right? It's only going to care about the local energies when you do this type of interaction. So it's not going to know its current count of bound occupancy sites, but it will get you the kind of the non-saturated regime, right, where your AREF is much greater than your A adhesion. So that would get you most of the way, but unfortunately not all the way. But that is the correct answer, because effectively we're going to do that. But we're going to also have to but we're going to also have to modify the energy functional, right? So we want to include this term. So the energy contribution in our change of energy would look like our delta H, right? Our new minus our old. So to implement this term, we will need to modify the acceptance evaluation, i.e. our energy function, but we also need to know when we have an acceptance event, i.e. the lattice monitors, to change the cell occupancy. But first, we need to learn how to compile CompuCell to even allow us to do these types of actions, right? So what do we need to compile CompuCell? One, we need the core code of CompuCell. You can get this through Git. We will be using 4.9 in these examples. But really, this workflow is the same. Outside of if you go back far enough in CompuCell, you used to have to lock the Python version, but don't worry about that. Python 4.9, or sorry, CompuCell 4.9 uses Python 3.12, and that's the context that we're going to talk about today. You need Miniforge, Miniconda, or Anaconda. I will be showing you from Miniconda. I would prefer Miniforge. I have Miniforge on my laptop, but I'm not going to destroy my Miniconda because my Miniconda environment. But any of those work. You will need a compiler. Depending on your OS, this will change. We will go over that. And then really for this module, I'm going to be walking through in the context of Windows, but I'll cover how to set up Linux and Mac environments also while going through this. Right. So to get your own copy of CompuCell, all you need to do is copy the CompuCell GitHub repo. CompuCell is open source, of course. So you can do this a couple ways. You can use a git command where you say git clone at GitHub, your GitHub name, CompuCell3D.git, where you first cd to some path, right? This is basically saying, hey, put all these files on this path. That's if you want to contribute. If you don't, you can just clone the CC3D repository. So same idea, go to some path to git clone, GitHub, CompuCell, CompuCell3D.git. If you're even lazier, and this is what I find myself doing half the time, is you can just go directly to the CompuCell GitHub repository, go to code, click that, and hit download zip. Congratulations, you have the newest zip file of the core code. So if you don't even want to do Git, you can just directly download it from the CompuCell GitHub repository. Yes, so this is actually reminds me to ask something. How many people right now are following with me to try to set up their environment? This will help me in terms of pacing so that I'm not pausing, trying to give people time to get these components. So please let me know. Because if nobody's actually trying to compile, then I will probably not leave as long of pauses. You wish you could, but I haven't. You should just be able to make a few environments as long as you don't have issues with Miniconda or Miniforge clashing from some environmental paths. Okay, yeah, I mean, we can talk about that later if you do want to set up an environment, you need help, Clara. But yeah, as Lorenzo said, you are creating an environment, so it should be isolated, and you can do that. So I'm going to assume that if you're going to create a clone or just download the zip file of the repo, you've done it. right? So you'll also have to do the same with the Player and Twedit repositories. So you can do a clone on the repository, or as said before, you can just download the zip file if you don't want to do the clone command. So next, really, you're going to need to get your compiler, right? So for Linux, you're going to use OpenGL. That's really included. So you have two options, depends on which Linux operating system you are, and how to target them changes slightly. For these two examples, these are for Ubuntu, but something like Red Hat, these can vary slightly, but you just need to know where your OpenGL library is. For Mac, all you need to do is get the OS X core developer tools, which can be done with Xcode select install. We sent an email about this. These steps do take a while because they are large files. So unfortunately, if you don't have these set up yet, it's going to be it'll be hard to catch up. And then for Windows, Visual Studio 2026, when you are installing it, make sure to select desktop development with C++. If you've already installed it and you forgot to select that, it's not a big deal. You can just go Tools, get Tools and Features, and then you'll see Desktop Development with C++. That'll pop back up and you can get it installed after the fact. So you don't need to fully reinstall Visual Studio 2026 if you forgot to do that. So now we're back at setting up your Conda environment. If you did try to do that, I hope it got through. I think it usually takes me somewhere around 5-6 minutes, depending. To create this environment, it's a pretty large environment. If you take a peek at what this YAML file has, there's a lot of packages that's just going to try to load. So yep, again, Windows and Conda Forge Mini Forge, you're going to do Mamba and create. I do see one person is saying that they need more time. If I did move past where you're currently stuck, please let me know in chat, and then I can try to quickly remind you of any of those. So in Windows, you're going to do this sort of path. If you don't have Conda Forge install, if you don't have Mamba installed, you can do it with this command, conda install c conda forge mamba, and that'll let you run the Mamba call. It's very worth setting up Mamba. Same for Mac and Linux. If you do need the YAML, I did see the YAML links were posted in the chat. So please reference there. If you still can't find it, you can send me an email after the fact, or go to the documentation. These are really just links to the documentation. The YAML files are in there. So next, we need to set up the environment and file paths. This will probably be the first place where you'll start to hit a couple bumps in the road. What we're basically doing in this set is setting up the CMake so that it knows where our source files are, where the build files that it's going to try to build, where it's going to put the build files are, and then where it's going to make the install files. It's also going to set the target for the compiler, and then a few options, which we're not going to go into the options. The big ones you need to make sure are correct are that your source file is targeted correctly, the build file is targeted directly. This one can be an empty file. I mean, it's going to create all these build files into there. For Windows, this is where it will put your solution file. And then you need to make sure your Python executable is targeted correctly. If you are in your current environment you plan to build CompuCell into, it should be able to retrieve the file path with the Conda prefix, as long as you're in the activated environment. Going back, I did quickly skip over this. Before you do this, make sure you activate your environment. So Conda activate or Mamba activate your environment name. Your environment name is, in the YAML file, name at the top is what the environment will be created as. You can also do Conda env list, and it will tell you all your environment names if you do end up forgetting it after the fact. So when I say these are very exact, they are very exact. If there's a space that's incorrect or anything, it's going to freak out and it's going to not be able to evaluate the CMake command. It can get annoying if you do accidentally add spaces. So, you know, it's okay, it happens. Just find where the likely space is or the accidentally removed spaces and try to find and try to fix it. It'll be okay. So as a note, if you are using older versions of Visual Studio, you're going to change the compiler to Visual Studio 14 or Visual Studio 16. But for me, these are pretty easy. We should have, yeah. So for me, this would be the path to my environment, and I would end up saying, we go here, yeah, and then it'll target this Python file, right? So for Macs, same idea. You are just creating, your compiler will be different. It's just Unix makefiles. And then for Linux, you're doing your OpenGL, you're doing your OpenGL library. For Mac, it's just this command. But the same idea, right? You're pointing to your source file, you're pointing to a build file, you're pointing to your Python executable of the kind of environment you want to build it into, and then you're selecting a place that you will be putting your install files. Right? So my CMake input would look like this, right? There's some folder src that has this CompuCell repository in it. In the same src file folder, I'm making a new folder called CompuCell build. I'm targeting my Python executable in the Python environment that I currently have active. This one is using Visual Studio 2026. And then I'm targeting a different folder called install projects, CC3D compile 2026 to put the install files into. This last argument is less important. It does need to have a point. You used to have to drag these install files into your Conda environment, but now it will automatically target it. But now it will automatically target it. So when you run the CMake, you'll get some feedback, and then it'll say build files have been written to your build file. Right. So I will actually show you in Visual Studio. I'll actually, no, I probably should have just kept that. All right. So I'm going to say, so I'm going to open, I'll build the VCX proj. This is the file that you're looking for. This is your solution file. You can just hit open file or solution. And then for me, this one is this, and then this is your solution file. Or sorry, this is your solution file, all build VCX proj, right? So I can then open that. And then it'll load the solution. On the right-hand side, we'll see our solution pane. And there's two things that you should be most concerned with. Number one is this all build argument. And number two is install. Right? So you can also do it from the file path, file, open, project solution, and then same idea, go to your build folder, find all build VCX proj, and then open it up. Couple notes, in the solution pane, anything with shared behind it, really all of these are source code folders. You can open them up from the solution pane. So say you want to open up chemotaxis, you can find chemotaxis shared, expand it, expand source files, and now you can get to the CPP files to modify it in whatever way you want to be fit, any way you see fit, if you don't want to have to file path to it and open it up separately. All right. So this is very important for the Windows compiling. You need to set debug to release. If you do not, Windows will become very upset with the Python linkers, and it will not compile. You will get errors. So in order to get it to actually compile, you first need to set it to release, and then you can build all build, right? So here you can see on this drop down, I have mine set to release. And then I can go to all build, I can right click, and then I can say build. All right, so I will actually do this. What you will then see is it'll do build started, and you'll watch it go through its actions. This can also take a while to complete. So one important note, again, if the build fails, please make sure to check if release is selected. If it continues to get errors, then you can, if you continue to get errors, then it's likely something else. Sometimes it can be something weird, like linkers weren't built correctly, or sometimes it's a typo in your generated code. So once that is complete, okay, you'll see build 2 succeeded, 0 failed, 86 up to date. If it's your first time, it'll say they all succeeded. I have already pre-built this environment. Once you've done that, you can then go to install, and you say build on install. And what install is doing is it will now start to drag the files over. Oh, good, it did what I thought it would do. So mine errored out. Mine gives me the error, the command set local. Now, this is an easy fix. This just tells me I need to run this elevated, right? So all I need to do is close out of this, go back. I can do this, run as admin. Reopen my solution. And then I can go and say build. And now I should not have an issue. Yep, as you can see, it succeeded, right? So we've now built it, and we are done there. So for other OS compilers, really, for the most part, what I'm doing is I'm walking you through the developer's manual. For the other operating systems, it's even more simple. You don't need to do all this extra effort with Visual Studio. So it is pretty easy to follow the documents. If you do hit issues, feel free to really ask anyone. And if the first person you ask doesn't know how to answer the question, they will definitely know who to ask to answer the question. So congratulations, you possibly compiled CompuCell. But likely you want to open and view the GUI to make it look like the previous, how you would have seen it previously if you just ran something like the executable. Now, in order to see the GUI, we just need to do a few easy steps. So first, we need to find the location that you saved the Player and Twedit repos to. And then next, you need to copy those into your Python mini Conda mini forge environment through either this xcopy command, where you're just saying, here's where my source code is, and I want to copy it into my CC3D compile environment with some options. If you don't want to use xcopy, you can always just manually drag the folder in the environment you want. So for instance, for me, I can go to lib. So I'm already in, I'll go all the way back down, right? So this is my mini Conda folder. It's in program data. Program data is a hidden folder. If you can't find your hidden folders, you can click down here. I think it's options, and then there should be show hidden. Or, no, sorry, it's just view and then show hidden, right? So if you can't find your program data, if your mini Conda or mini forge is in program data, you can find it with view, show, hidden, if you're using the Explorer pane. Right, so mini Conda environments. This is my current environment that I'm concerned with. So this one's 4.8. There's really no difference between 4.8, 4.9 in the workflow. And then we can go to lib, and then site packages. And then we are just looking for CompuCell3D, right? So this is where you want to target first, right? So in your environment, lib, site package, CompuCell3D, and you can see I've already dragged these folders, Player 5 and Twedit 5. I can go to here, and I can show you for the I can show you if I go here and I say Twedit. We'll just do this as an example. Extract all. Extract. It's going to create something there. It's going to be okay. Yeah, sure. You can replace all the files. That's fine. That folder already existed. All right. So then it'll open this repo that we've now unzipped, and go to CompuCell3D, right? So Twedit master, CC3D, and then this Twedit 5 folder is the folder that you can just literally drag and drop. Only the folder, don't touch the init. But you can just drag and drop the folder into your environment your environment site packages in the CompuCell3D folder, and you will now be able to you now should be able to open up, right? So all you need to do is start your environment and run this command, which will look exactly the same as if you Conda installed it, or I guess Mamba installed it. So then you can just run, so this is my environment. You can just run python .m cc3d.player. I could type, that'd be helpful. Player 5. Right, you can hit enter, and it'll open up the GUI. And you've now hopefully compiled CompuCell. So because we didn't have many people following along, I could get through that a lot faster. So that is kind of where I'll leave it. Your homework, you can try it yourself. Follow these steps. Really with extra time, if you do want to try to compile it now, we can, or I or somebody else can help you get this environment set up. But for the morning session, that's really it. It kind of goes fast if I don't have to wait for all of these long commands. Do I have any questions, or is anyone unclear exactly on when you would want to be doing this compiler?
I mean, one thing that might not be a terrible idea is if people who haven't followed through on this, but watched the video, but didn't watch the lecture, but didn't do the exercises. If somebody wanted to screen share, Michael could probably walk them through it if you want to do that for 1 or 2 people. We can set up the screen share to allow that if people are interested.
Yeah, and if you don't want to screen share, we can always do a breakout room and then walk you through it if you don't feel like you want to share everything to everyone.
So we have 20 people here. I don't have much of a sense of how many people are actually going to be compiling CompuCell. It's not trivial. It's not trivial to do for everybody. I mean, most of the time, CompuCell is designed so you don't have to recompile it. That's why we have the Python scripting. But it is valuable to be able to extend it. We definitely would appreciate more developers in our world. And so we want to take the time now to help people learn how to do it if you want to try. So you've got an expert here who's happy to sit with you one-on-one and walk you through it again.
Yeah, as I said earlier, the largest use case is if you actually want to do modifications to the Cellular Potts core in a way that isn't already provided in a plugin. We have a lot of plugins, but you can't have everything. So if you just want to play with some sort of different energy functional, you really do end up having to compile CompuCell. Or if you want to modify a plugin to do something a little bit more right, that in a way that you need it done, as opposed to the way it's natively handled. So when you do Mamba and create, what you're basically creating is the environment. The path to is just the path to the environment. You're going to run this in your base MiniForge command line, right? And then MiniForge will then read this YAML, and then create an environment, download all these packages that the YAML file specifies, creates the environment, which then you can activate. That means you got the, I'm going to do so bad with names. I'm apologizing. Raghu. That means that you have the your compile environment, or you've created your environment. So the YAML file worked. If you ran it, and you can now open it. So for Kyle, you're trying to develop a pH calculation plugin for the hackathon. I guess it depends. before I give suggesting considerations, is what's the functional role of the pH, or what do you expect the functional role of the pH to be in your simulation? Do you have MiniForge open? Can you open MiniForge? What it's basically saying here is that you don't have, it doesn't know the Conda call exists. Or, no, you're trying to put on Mamba. It just doesn't know what Conda is. If you, you're also using it in PowerShell. So make sure that it's actively, that you're in this base MiniForge environment, which I don't think you are currently in. For Kyle, there's probably a few ways you can do it. You could probably get pretty good approximation by just using the Steppable, then have it affect some sort of a growth term. Otherwise, you could use a plugin that reads field concentrations, and then tries to update the growth rate in the sub-MCS. But for the most part, you should be able to get good results if you just use a Steppable. And then the just, yeah, have standard growth at every MCS. Or you change your target volume. So, right. Set this. So when you're in a Conda environment or a Mamba environment, this is what you want to be looking for in front. It's these inside the parentheses, right? So if I can go Conda deactivate, and I will leave this environment. Oh, okay, I can't spell. Right, and now I'm in the base environment, right? If I want to re-enter it, I say Conda CCP, and I will re-enter this environment. You two are not in your environment. So you're in the folder path, but you need to make sure that your Conda environment is actually active. So for mini-Conda or Anaconda, you can directly open it from Anaconda prompt. I think MiniForge has something similar. And then you'll know that you have this active correctly because you'll see the environment name before your folder path. It is using CMake, but I don't know the solution to that immediately. So how do you handle several versions of CompuCell3D? The easiest way to do that is just having different environments. So I can actually show you here. So I can kind of end. This is the command. Oh. All right, I forgot the command. So I can just say Conda debate CC3D. I think I have 4.6 on here. So I'm now in CompuCell 4.6. It's as easy as that. These environments are all separated. So that's how you can do it several versions of CompuCell 3D When you say the location of the CompuCell3D folder, I'm guessing you mean the source files. You can have as many versions of those as you want. So normally what I would have is basically the source files for multiple versions of CompuCell. Even for same versions, I could have multiple source files if I have very specific modifications in them. Really, that only matters when you're targeting your CMake command with when you're pointing to your source files, you just need to make sure it's pointing to the correct source folder. You can rename it to remember which is which. Again, you just need to make sure that the file path is correct to the source files. And then the Player and Twedit clones go in your CC3D folder in the packages. So I'll just copy and paste this. This won't be your exact path, but it'll give you the idea of how to path down, right? So for me, I'm in Conda. Forge is the same. They'll have an environment folder. You can go to your environment name, lib, site package, CC3D, and that's where you want to drag your Player and Twedit 5 folders. You're in your system32 file path, Arithra. Is that really where your CC3D YAML file is? Okay, good. I was a little worried. So in the afternoon session, kind of as a teaser, we probably won't have time to fully define this. There's a lot of little things, but we will go through the kind of pseudocode that sets the backbone of this plugin. So we're going to create a plugin that we will call Adhesive-Sat. We are going to define a few terms that are accessible through the XML. So then you don't need to recompile if you want to just do a couple of changes. Right, so for this one, it's enot aref. And then we are going to run this, right? So for some of these things, we're not going to really go into details like this. This is just some pattern that was created in CompuCell in the C++ layer, right? So there's some shape here that is adhesion sites. We initialize a single cell. We will write it so that we can initialize multi-cells. And then you can run that, and you'll see that it'll try to spread across these adhesion sites in a different functional way. And all of these energy values are controllable, so you can make it more favorable to these sites, give it more sites it would want to bind to, and you can see how the shape of this cell on this pattern surface will change. So what we were doing is adding this energy term, and then we will be doing just surface energy and contact energy, and you can get these sorts of shapes. So as you can see, it decided that it wants to move down the bottom of this Y with these parameters given here. So that's what we're going to be trying to make later in the afternoon. Though I will say it's a bit ambitious. At the very least, you will be provided with the code that runs this. So then you can kind of parse through what exactly it's doing. So For instance, I can make it want to have more sites. I can run it again, and you'll see the behavior changes. So that is what we will try to build in the afternoon session. Do I have any more questions on compiling or issues in terms of setting up this environment?